Okay, I'd like to talk about factoring some more. We're going to talk about factoring by grouping this time. So we have talked about factoring already, like for example, 6x plus 5x. Well, we know that that would really be, 11x, but ignore that for now. I want to factor it. So I've got a highest common factor of x. I can take x out of both. And I have x outside of 6 plus 5. Oh, by the way, it's important to recognise that in a previous video I talked about the idea of two numbers being co-prime. When you have factorised correctly, you will find that the numbers inside of the brackets will be co-prime. That's a really important thing to pick up here. So the 5 and the 6, what factor do they have? What do they share? Well, the only thing they share is a 1. So they are both co-prime. So I know that I factored that correctly. Okay, let's move on. Let's have a look then at something a little trickier. What if I have got 6 outside of x plus 3 plus y outside of x plus 3? Well, what is the highest common factor here? Interesting. The reality is, this first example, this x, well, this really could be this. If you have a look at those two terms with the red I've got underlined, they are basically the same. My x up the top up here, that x could be anything, including x plus 3. It could be that. So when I had that, well, I knew that that was a factor, and that is true of here too. I've got two terms here, right? My two terms, let me undo all that red. The two terms that I have is 6 outside of x plus 3. The other term I have is y outside of x plus 3. So if I could find factors, the highest common factor between my two terms, then I'm going to be able to factorise this thing. So what are my two factors? Well, let's go back to that first instance. I had x in both of them. My highest common factor was x. Well, here, my highest common factor is actually x plus 3. So I can write that down as my highest common factor. It'll be x plus 3. Okay, so what did I do when I had a highest common factor before? Well, what I did is I took my highest common factor and I wrote it down out front of a new set of brackets. Okay? Oh, I actually had this set up to show that these are two terms. That's what we're dealing with, these two terms. Okay, so I'm going to take my x plus 3, which turns out to be my highest common factor. Okay, and I'm going to write it out the front of my brackets, right? And then I'm going to think about what I'm going to do next. Okay, so here it is. I got my x plus 3. That's the bit. But what did I do before? Let me bring that back down just a little bit. Well, I opened up a new set of brackets. Okay, so I need to do that here. I opened up a new set of brackets. Very good. What did I do next? Well, let's go back to my first one. Well, I had left over a 6 plus a 5, which I wrote inside of the brackets. Well, what do I have left here? 6 plus y. So let me write that down. 6 plus y. And guess what? We factorised it. Okay? We found the factor. Let me get rid of this red line here. So once again, let me say that the highest common factor can actually be more than just a number. It can be something in a bracket, just like I showed here in these two terms. That highest common factor then, once again, it goes out the front of as the common factor, the highest common factor. We then open up a new set of brackets and we write what's left in that box there. Now, I was very nice and kind, and I really did it to show, but I actually gave you that with these two common brackets to start with. That's not normally the case. Here, let me go through an example. Okay, here I have got some terms. I've got 2x squared plus xy plus 6x plus 3y. First thing I always try and look for is that highest common factor. Do I have a highest common factor here for all of these? Well, let's have a look. Factors of 2, No, I can't get a factor of 2 out of there or out of there. That's no good. X, I can here, I can't here. All right, so there is no highest common factor that's shared between all 4 of these terms. And that'll often be the case when you're dealing with these polynomials. Lots of different terms. Okay, so what do I do? Well, we will factor by grouping. So what we're going to do is we're actually going to split this up into 2 different groups, and we're going to look at the different factors of the groupings. Okay, so let's just consider this first group. 2x squared plus xy. Does it have a highest common factor? Well, it does. It's an x. What about this group? Plus 6x plus 3y. Is there a highest common factor? Well, there is. I can take a 3 out of both of these terms. Okay, so let's rewrite what we have got based on what we've done in the past. We're going to write that highest common factor outside of a new pair of brackets for each of these terms, okay, for each group here. And it's going to end up looking like this. I'm going to have my highest common factor of x right here out the front of a new pair of brackets. Now, as I write these things in the brackets, I'll divide each of these terms by the highest common factor. And I'll do the same on this other part here, highest common factor of 3. Well, 3 divided by 6x gives me 2x. 3 divided into 3y will just give me y. Now, I hope that you can see that if I've done this correctly, I'm going to end up with a common factor inside of these brackets between these 2 terms. Okay, so now I am back where I've got a common factor between these things. I'm going to take that common factor, 2x plus y. I'm going to write that out the front of my new, where I'm writing my factors, right? There's my new one. I'm then going to open up a new pair of brackets and write what's left. What's left is x plus 3. Okay, so as you can see, factoring by grouping got us to the answer when we couldn't find a highest common factor to start with. We'll go through another example because I think it's through doing the examples that you actually see and appreciate what's actually going on with this factoring by grouping. All right, let's do another one. Here I have my groups, all my terms, 4x cubed plus 5xy plus 4x squared plus 5y. Always ask, is there a highest common factor? There isn't. We're going to have to factor by grouping. We're going to have to split this up into some groups. Do I have some highest common factors here? Well, let's have a think about it. I'm going to have an x. That will be my highest common factor here. And over here, interesting. Let me show you something. When I actually apply the x out the front of this particular one here, so I divide x into here and it'll give me 4x squared plus 5y, and then I look at this grouping over here. Well, this grouping over here didn't have a highest common factor, or did it? Well, it's exactly the same as what I've got here. I've rewritten it, and that is a common factor, but there seems to be a highest common factor missing here. And here, the highest common factor is just a 1. Right? I could write that plus 1. In fact, I recommend it so you don't get lost. There is just a 1. That is it. Apart from that, these 2 terms back up here, they're just co-prime. There's no other factors between them. So except for that 1. And this time the 1 is actually useful. I can now rewrite my common factor of x squared plus 5y out the front of a new pair of brackets. And what is left will be x plus 1. And now I have factorized that. All right, let's have a look at another one. You can, of course, pause this and rewind this and watch them as you go. Let us have a look at this one. And I've already got it set up so that we can look for what the highest common factor of each of these different groups are, because we don't have, Now, this one's a little different again. Up until now, I've been pretty nice to you, and I've only gone through examples with pluses. We've got to think about the process of minuses as well. We need to do that. Okay, so what's the highest common factor of my first group here? Well, it'll just be y. That's all I've got going on. But what's the highest common factor of my next group? Now, this minus here means that we're going to have a minus in our grouping as a factor, in that highest common factor group. All right, so what will be the highest common factor knowing it has to be a negative number? Well, looking at my numbers there, I know it'll be -2. Okay, so if I do these divisions and rewritings, I'm going to have the highest common factor outside of new pairs of brackets. Well, let me go through that for you, and we'll actually figure that out. Here I've got my y and my -2 that I said were the highest common factors of each of those groups. What do I have here? I'll have 2x plus 5y, and over here I will have, now this is important that you go careful, I've got -4x and I'm dividing it by -2. What will that be? Well, it will be 2x, and I have got -10y being divided by -2, and a negative divided by a negative is a positive. It'll be +5y. And it's important to know, if you've done this right, you will end up with the same coprime terms inside of these brackets so that you can actually bring them out as a common. And when we recombine and rewrite them, we're going to end up with, well, 2x plus 5 in brackets outside of y minus 2 in brackets. Okay, I want you to pay attention and make note that the negatives make things a little more interesting. You have to think about what you're doing a little carefully. Let's do another example, because the examples are where the real value is. Here I've got my terms, 3xy minus 4 plus x minus 12. I know that there is no highest common factor. Now you might think it's strange, I'm always checking for that, but you should. You always should check for a highest common factor because it makes things a whole lot easier if you do. There's no highest common factor. I can factor by grouping. So let's do that. All right, well, let's have a look. 3xy minus 4, the highest common factor is just a 1. Well, okay. What about the x and -12? Well, the highest common factor is only a 1. Now, we have had a highest common factor of a 1 be useful before, but in this instance, when they're both 1, that is not useful. That's not useful at all. I can't use this, and I can't factor by grouping because there's no other factors but 1. What we can do, because addition is cumulative, we can shift things around a little bit so long as we keep the signs the same. So what I'm actually going to do here is I'm going to swap my middle terms. I'm going to swap my -4 and I'm going to swap my plus x. So let me rewrite that. It will be 3xy plus x, -4, -12y. I'm going to try again. I'm going to have a look to see if there's any highest common factors in those groups. All right, so let's have a look at the first one, the highest common factor. Oh, I'll go back to my yellow. My highest common factor will be an x, and my highest common factor over here will be -4. And I'm remembering that because there's a negative here, my factor will have to be negative. Okay, all right, so I'm going to factor these out, and I'm going to end up with, and I'm not going to go through this step by step because I've done a few of these now. I'm just going to point out the fact that with this being a negative factor at the front here, that will change the polarity, I guess. They'll make this, which was a negative before, a positive, and this a negative, a positive. I have something interesting here. 3y plus 1, and I have 1 plus 3y. Are they the same? They are the same. Addition's cumulative. You can do them in any order you like. Okay, so I can still rewrite that as a common factor outside of what's left over. And you will see there that we have managed to find the factorized form. We had to do a little extra step, and if it doesn't give you highest common factors apart from 1 on both of the groups, try flipping the middle, and if it doesn't work, then maybe there are none. We might do one last example. We've done lots of examples, but it's important to know all the different possibilities and combinations of things that could happen. This one's a bit longer, so we have to push it over a bit. Okay, so we have got 12 xy plus 12, yz minus 4, xz minus 4, z squared. What's the question we always ask ourselves? Is there a highest common factor? Well, there is. There actually is. So my highest common factor in this instance is going to be a 4. Doesn't matter about the x's and the z's and the y's and stuff, because there's no common factors amongst those. It's just a 4. So when I write my next line, I'm actually going to make sure that I think we've lost the 4 there, but it's a bit wide. I can't fit it in. I'm going to have a 4 in a funny pair of brackets, just so I know that there is a factor that is common, a highest common factor out of all 4 of those terms. Okay, so am I done? Have I factorized this? You might think, well, I factorized it, I'm done. But no, you're not done yet, because we can factorize this further. The reason we know that it's not factorized further is, well, it doesn't look like those other ones that we've just done before. Okay, so once again, and I'm going to sort of go through this a bit quicker, I'm going to look at my pairings, right? I'm going to look at my groups. Here's one group. Here's one group. I'm going to look for the highest common factor in each of these. So the highest common factor out of the first one will be 3y. Highest common factor out of the next group will be, well, now I have to be careful. There's a negative here, so I know that my answer for my highest common factor needs to be a negative. It'll be negative z. I'm going to rewrite those with the highest common factor outside of a pair of new brackets. In each of these instances, I'm then going to gather my highest common factor out of these terms, and I'm going to rewrite it, and it will look like 4 outside of x plus 2 in brackets multiplied by 3y minus z in brackets. Now you'll notice that I've dropped those big square brackets on the outside. You don't have to have them in the final answer. Could I have them? Yeah, I guess I could have them. Do I need them? No, I don't really need them. That's entirely up to you. If it makes you happier to keep them there, then keep them there. But you will notice that it is very important that we took that highest common factor out at the very beginning so that we could get to this answer. Okay, so lots of examples there. But this factoring by grouping has a lot of power, and it becomes more important as we start to factorize out trinomials in the future, especially some tricky ones.